Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following quadratic patterns or quadratic sequence. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. Consider the following number pattern: 6, 13, 22, and 33. Where to A, show that it is a quadratic pattern, B, write down the next two terms of the number pattern, and determine the nth term as well as the 100th term, and D, determine which term equals 118. Going by the first part of the question that says, show that it is a quadratic pattern. A quadratic pattern is in the form Tn equals, that's the nth term, an squared plus bn plus c. And what shows that a pattern is quadratic is that the second difference is the same. So if you list out a pattern, we have 6, solving the A part of the question, we have 6, 13, 22, and 33, and so on. To show that it's a quadratic pattern, we just need to show that the second difference is the same. So I'll start with the first difference. It's the number in front minus the number behind. We have a first term, second, third, and fourth. So to find the second difference is going to be T2 minus T1. In this case, we have 13 minus 6, which is 7. 22 minus 13, which is 9. 33 minus 22, 11. That's our first difference. The next step is to find the second difference. So we have second difference. Note that that's the number in front minus the number behind. So it's 9 minus 7. That's 2. 11 minus 9. That's also 2. So we can see that the second difference is the same. So we have, therefore, 6, 13, 22, and 33 is a quadratic number pattern because the second difference is the same. Let's look at the second part of the question, which says, write down the next two terms of the number pattern. For the second part of the question that says that we should write down the next two terms of the number pattern, we are going to work backwards. Remember, we mentioned, or we've been able to prove that the second difference is the same, which is 2. What it means is, if we add 2, 7 plus 2 will give us 9. 9 plus 2 will give us 11. Therefore, 11 plus 2 will give us 13. And if we're going upwards, we're going to do the same thing to show that if we have 6 plus 7 will give us 13, 13 plus 9 will give us 22, 22 plus 11 will give us 33. Therefore, 33 plus 13 will give us the next number. 33 plus 13 is 46. We need to find the next number again. The common difference, where we're starting from, common difference is 2. So therefore, 13 plus 2 will give us the next number, which is 15. And the last combination will be 46 plus 15 will give us our next number, 61. So therefore, the next two numbers are 46 and 61. For the third part of the question, which says, and determine the nth term as well as the 100th term. To determine the nth term, we know that the quadratic pattern has the nth term given as Tn equals an squared plus bn plus c. The a I'm starting with the A. To find the A, that's half of the second difference. We're able to show that the second difference is 2, so therefore A is equal to half of 2, which is 1. I'm going to show you quickly how I got 2 for my second difference. I have the number pattern 6, 13, 22, 33, starting with the first difference. I had 7, 9, 11. Then the second difference, which is 2. We have this as the first difference and the second difference. So therefore, we've been able to find the value of A. We need to find B and C. To find B and C, the formula goes that the second term minus the first term is equal to 3A plus B. Note that the first term is 6, second is 13, third is 22, and so on. So therefore, taking our first and second term, we have 13 minus 6 is equal to 3 times A, we know A to be 1, plus B. 13 minus 6, that's 7, equals 3 plus B. Therefore, B equals 7 minus 3. Therefore, the value of B is 4. To find the value of C, we have the first term equals A plus B plus C. The first term, as shown, is 6. So we have 6 equals A is 1 plus B is 4. And then C, 6 equals 5 plus C. Therefore, C equals 6 minus 5, which is 1. Therefore, our Tn equals A, which is 1, n squared, 1 times any number remains the same, plus Bn, B is 4, so we have that as 4n, plus our C, C is 1. So to find our nth term, this is a formula to use, and from here we can easily find our 100th term, which will be T100. Every occurrence of n replaced with 100. So we have 300 equals 100 squared, as n squared, plus 4 times 100, plus 1, that's 10,000, plus 4 times 100, 400 plus 1. Therefore, the value of our T100 equals 10,401. Let's go to the last part of the question. The last part of the question says we should determine which term equals 118. Note that we've been able to find out Tn. Tn is equal to n squared plus 4n plus 1, which will be equal to 118. So basically, we are finding the value of n. Moving all the terms to one side, we have n squared plus 4n plus 1 minus 118 equals to 0. We are turning it into a quadratic equation. We have n squared plus 4n minus 117 equals to 0. Factorizing, that's equal to 0. We have that as n plus 13. N minus 9 equals to 0. Therefore, we have n plus 13 equals to 0. N equals 2, moving our 13 to the other side. Or we have n minus 9 equals to 0. Therefore, n equals to positive 9. Note that we can have a negative number as our n because we can have a negative position. So n cannot be equal to 13. We have that as no solution. Therefore, the nth term that will give us 118 will be the 9th term. So the value of n is 9. Thanks for watching. Bye. We have 9th term. equals 118.